This is the second assignment for the first quiz in the second try. I'm going to try to do samples today where we have a cubic, a degree 3 multiplicity on a factor. So I'm going to do 6, 7, 8, and 10, and then the rest are for you to do. Again, you're going to want to have this set of notes to guide you through. And I don't care that you do the standard form equation. Okay, that's just very time consuming, but know how to, so you might want to practice a couple of them as you do this. So our degree on this first one is 4 because we have a 3 and a 1 power. And you're going to add those together. Leading coefficient is positive, it's a 1. So it's 1 cubed times 1. The y-intercept is -2 because we have -1 cubed times 2 to the first. So we're taking that n number, -1 here to the third, and then 2 to the first. So maybe you do need to multiply 1 out just to see that the leading coefficient would be what's multiplied by x to the third. And then the y-intercept is that number on the end after you're all done with expanding. That's what those are. So we have an even positive. Even positive means the end behavior on both is infinity, infinity. And there are reasons for that. So because of the even power, all of your large values get raised to the 4th power. So everything's positive that's turning into a large value, even the negatives that are large, large negative values. So there are reasons you can think about why are they both positive infinity? Why are they both negative infinity? Why these things happen. Okay, so 0, we have a -2 and a 1, and an x plus 2 and an x minus 1. Remember, the multiplicity is the power on that factor. So 1 has a multiplicity of 3. So here's where you're going to see this turn flat. So you do want to get in the x-intercepts and the y-intercept. So we have this kind of coming through like this, and it's going to come down here, and then it's going to come back up, and it's going to get real flat at 1, and then come through. So again, I'm not terribly concerned how low, what that point is right there right now, and you might not be low enough. Maybe the graph shows it coming through a little bit lower. I'm not concerned about that. I'm just concerned about the nature, that you get this flattening out here, you get the y-intercept and you get the x-intercept. Again, read through this. It will help you in your struggles. Okay, problem 7. Notice again that we have this, so you need to go to a zero finder and you enter this in. Literally, if you type this into a search bar, I'm telling you, you would get a triple root of -1 and a triple root of 2. I'm sorry, double root of -1 and a triple root of 2. So it looks like I gave you a little bit of help there with this. The degree is odd because the sum of the powers is odd. The leading coefficient is positive, it is 1. -8, so 1 squared times -2 to the third. This was 1 squared times 1 to the third if you wanted to exactly know. And then, so we have an odd positive. Okay, so odd positive means that as you're going out way to the left, those negative values, when you raise it to a degree of 5, that's a negative. And so that's taking over, meaning your y values become extremely negative. As you go out to the right, it doesn't matter. A positive odd raised to the fifth power, I should just say positive number raised to the fifth power is positive, and that takes over. So it's this. You have to look at that leading term because that takes over. That's how you're actually deciding the left and right end behavior, is you look at that lead term and the leading coefficient. That's what tells you for sure. Okay, so x plus 1, x minus 2. And so we're going to hit at negative 1. Put negative 8 in here. So we're going to come up like this, and we're going to bounce back the way we came, down to negative 8. And then when we come up to 2, so it kind of cuts through, goes lower here, and that's something you can check out. It gets flat and then coming through. So the turn was below 8. And you probably should give it a, oh, let me get on the screen here. You probably should give it a look on the graph. I use my magenta colored pen so that you can see easily as you do this, but I would want to see the flattening here and then the bouncing back here. That's the whole point, is to be able to see the basic things, features on the graph. So here we go, number 8. This is going to be 2. We'll have a multiplicity of 3. That's it. That's the only 0. So this is x minus 2 cubed. You would see 2, 2, and 2. You might, again, get some error in the polynomial because it's not perfect. Odd positive. So an odd positive means, and then the y-intercept is negative 8. Well, duh, we can, okay, so I was doing all that work. The y-intercept's right in front of you. The leading coefficient's right in front of you. When you have the standard form, it's easy. 1 is the leading coefficient, and negative 8 is the y-intercept. I should have said that on the one before. You have this right in front of you. So here it is. Negative 8 is the y-intercept, and the leading coefficient is 1. So that's the, when you do this, that's what it's talking about, literally. Okay, so negative 8. There's my little advertisement again. Coming up. Getting flat through there because it's a cube. And that's going to be it. Remember, when it's a third, only when it's a cube or a fourth, so it will get flat. I'm not going to give you 1 to the 4th power, but if you looked at x to the 4th, you'd see it getting flat at 0 on the x-axis where it hits. And then number 10. So now you have the graph, and I can tell at 1, you see how it's flat there, that's a cube. That's a triple, and then negative 1 is in a multiplicity of 1. And now we're ready to write the factors above. So we have x plus 1 times x minus 1 to the 3rd. And this is even, positive. So this is 1 times 1 to the 3rd. Y-intercept will be negative 1. So this is 1 times negative 1 to the 3rd. And so even positive, well, you have the graph so you can see that they're both going towards infinity there. Once you get this, it really is pretty simple. The thing that's actually a lot of work is if I said expand this out, multiply it out. And there's a couple problems on these quiz practices and on the quiz where I make you do that. You'll see that. Okay, so the rest of the problems are for you to do.